Hi all, see this, in this particular problem we need to find out this limit, right? So we'll go ahead step by step, okay? First we write down this limit, limit x tends to pi by 2. So limit x tends to pi by 2, cot x minus cos x divided by pi minus 2x. Okay, cool. So that's it. Okay, now see that here, if x tends to pi by 2 minus x is tends to 0, right? So therefore, pi x equal to pi by 2 is definitely a singular point. So you have to somehow remove that. So first step, we just rewrite the limit in this form. So I write x tends to pi by 2. We use complementary angle formula. So therefore, tan pi by 2 minus x. Cos will be converted to as sine pi by 2 minus x divided by, if I take 2 common, so 2 cube, that is 8 multiplied by pi by 2 minus x whole cube. Okay. Now let's take h is equal to x pi by 2 minus x. That's it, okay? We just introduced a new variable. Why? Because see that in the denominator and numerator all are having that pi by 2 minus x term. So therefore we'll say that that's imply that h tends to 0 while x tends to 0. That's it. So therefore this given limit, let us write down the limit as L. So therefore in this case the limit L is equal to limit h tends to 0 tan h minus sin h divided by 8h cube. That's it. So therefore, we get some simplification now. Now see that here, sin h can be taken common, right? Because it is tan h. So what happened? So therefore, this limit can be easily written as limit h tends to 0 8h cube. If I take sin h common, we'll get it as 1 by cos h. That's I write it as sec h minus 1, right? Now, this L can be easily written as, let's take that 8 outside because 8 is a constant term here. Limit h tends to 0 sin h by h and multiplied by limit h tends to 0. Let's go ahead and calculate that sec h minus 1 term. So now I sec h, I don't want to use it. So therefore I need to multiply by cos h, right? So therefore we can get it as 1 minus cos h divided by h square into cos h. Now, why cos h multiplication? It doesn't give any problem because cos h, that means cos 0 is 1. So it doesn't become a singular point at this case, right? Now, that implies that it is 1 by weight and the limit h tends to 0, h is equal to 1. So that limit is left, gone. So therefore, limit h tends to 0. Let's apply that here. So in this case, I have to remove that 1 minus cos h, right? Because otherwise we can apply the so-called L'Hospital rule. So make it easy, but I don't use that, okay? So let's see that. So it is 1 minus cos h. So how will remove 1 minus cos h? So therefore we can see that using formula 1 plus 2 sine squared h by 2 divided by h square cos h. So therefore, this can be written as 1 by 8. This one is gone. So we can write limit h tends to 0, 1 by cos h multiplied by limit h tends to 0, sine square h by 2 multiplied by h square. Now this 2 we just able to write down here. So that therefore this can be cancelled out and become as 4. That's it. So that's the step we have to follow. So again, we can say that one limit is left. So limit h tends to 0 cos h is actually 1 by 1. So that's it, gone. So therefore you can write it as 1 by 4, 1. multiplied by. Let's see that. It can be written as limit h tends to 0 sine h by 2 divided by h by 2 whole square. Now here see that if I write h by 2 whole square, that means we are actually multiplying here by 4. So therefore we need to write 1 by 4 outside. So therefore you can see that here it became 1 by 16. So that's why 1 by 16 is the final answer. Why it's 1 by 16? Because here it is limits h tends to 0, h by 2 and all that stuff. So therefore next line we can write h tends to 0, that's why h by 2 tends to 0, and that's why the square, it will go inside the bracket and then it becomes 1, and that's it. So that's the limit for us. Hope you understood the problem. Thank you.